Topic is Gauss Law. So before we discuss Gauss Law, I hope you all know about the relation between electric flux and electric field, which is that the flux passing through a surface denoted by phi, it is integral EdS cos theta, where theta being angle between electric field and this area vector. So it is clear from here that flux is related to electric field, and as we know, electric field is produced by some sort of charge configuration, and electric field is related to flux. So that means there must be some relation between this flux and the charge. So this relation for a special case was given by this physicist Gauss, which is known as Gauss law. So this Gauss law, it is applicable to closed surfaces only. So closed surfaces means surface like a sphere, cylinder, and suppose cube, etc. So any closed surface we can consider for which we can apply this Gauss law. So for a closed surface, the flux and the charge, how are they related? So according to Gauss law, the flux passing through a closed surface, it depends upon the permittivity and the net charge enclosed inside. So this statement is known as Gauss law, which states that flux passing through a closed surface is 1 upon epsilon naught times of net charge enclosed inside the Gaussian surface. This is known as Gauss law. Clear? Now, as we know that flux is related to charge according to Gauss law, and flux is also related to electric field. So there is a relation between electric field and the charge. So for some typical type of cases, we will consider that how we can find out the electric field intensity using Gauss law in a very easy manner. So that is what we will discuss next, which comes under applications of Gauss law. So let us discuss some of the applications. Okay, now we'll understand how to find out electric field intensity using Gauss law. While finding out this, we have to follow some set of steps, in which the first step is we have to consider a Gaussian surface, and this Gaussian surface must follow at least these 2 points. The Gaussian surface has to be a closed surface, and second is this Gaussian surface has to be symmetric. So these 2 properties there must be in the Gaussian surface. Next step will be finding out the flux using this Gauss law. Next step is again we will find out the flux, but using the basic definition, which states that flux is equal to EdS cos theta. And the last step will be, see, we are finding out the flux once by Gauss law and then by basic definition. We will be comparing both of these equations. Suppose this is equation 1, this is equation 2. So in the last step, we will compare equation 1 and equation 2. So these are the steps which we are going to follow while finding out electric field using Gauss law. So these steps will be more clear to you once we start using them. So let us discuss the first application now. Okay, now we will find out electric field intensity due to a given point charge. Electric field intensity due to a point charge we have already discussed by using Coulomb's law, which tells us that electric field intensity is nothing but 1 upon 4 pi epsilon naught q upon r square, but today we will find out the same result by using Gauss Law. Okay, so suppose this is the charge q which is given to us, and there is a point at a distance r where I have to find electric field intensity. So this is a given situation. Now let us follow the same steps which I just told you. First step, we have to consider a Gaussian surface, and for this case the Gaussian surface, which will be a closed surface and which has to be symmetric, that surface, as you can imagine, it has to be a sphere. So this is the Gaussian surface which is spherical, and the center will just lie upon the charge itself. So this is the center, so radius of the Gaussian surface will also be r, and this is the point where we have to find out electric field intensity. Yeah. So this is the first step. We have assumed a spherical Gaussian surface. Okay. Now second step is we have to find out flux using Gauss law. So let us apply Gauss law for this closed surface. So flux through the Gaussian surface. So Gauss law, as you have seen, that it states that the flux passing through a Gaussian surface is 1 upon epsilon naught times net charge enclosed in the surface. And here this is the Gaussian surface. Inside the Gaussian surface the only charge is q. So flux by Gauss theorem will be 1 upon epsilon naught q net. So that means it can be simply written as 1 upon epsilon naught into q. This is equation number 1. Now next step is we have to find out the flux by this definition. Flux is equal to AdS cos theta. So E is electric field, ds is the small element. So we don't have any element over here. So let us assume one element. Suppose this is the element and its area is ds. So what about its direction? Direction of element will be along the area vector. So area vector will be normally outward. So this is the direction of ds. And because I am assuming this charge to be positive, so electric field due to this charge, it will be readily outward. So this is the direction of electric field as well. So that means what is the angle between electric field and area vector in this case? So theta will be 0 degree only. Okay. Now let us find out the flux by this definition. So this is step 3. Flux equals to integral E ds cos theta. Theta we have seen it is equal to 0. So cos 0 will be 1. Now here comes the role of this symmetric surface. Because the surface is symmetric, if I find out electric field at this point, at this point, at this point, due to symmetry, electric field will be same at each and every point of the surface. So kind of electric field is a constant over here. Electric field can be taken out of the integration. So inside we have integral ds, theta is 0 and cos 0 is 1. So we are left with this term now. Okay, so integral ds means what? ds plus ds plus ds plus ds plus ds, and this closed circle tells us that we have to consider it for the whole sphere. So we'll get the area of the sphere, surface area of the sphere, which is 4 pi r square. So this flux will be E into 4 pi r square. This is equation number 2. Now, so what is the next step? We have to compare equation 1 and equation 2. So these are the equations we are having. So if I compare them, what do I get? Comparing 1 and 2, we have that E into 4 pi r square is equals to q upon epsilon naught, and from here we get the same result, that E is equals to 1 upon 4 pi epsilon naught q upon r square. So this is the same result which we obtain using Coulomb's law. So that means, again let's have a look upon this, what we have done. So we have been given a point charge due to which we had to find out electric field intensity. So this point charge Q is there, and there is a point P at a distance R where we have to find out electric field intensity. So first step was to consider a Gaussian surface. So we considered a Gaussian surface which is spherical. So this is the Gaussian surface shown by dots. Next step is to find out flux using Gauss law. So we have applied Gauss law over here. Gauss law states that flux is net charge upon epsilon naught. So because the only charge inside the surface is Q, so flux can be written as 1 upon epsilon naught into Q. This is equation number 1. Next step is flux, but by the definition EdS cos theta. So we have assumed one element over here, ds, which will be radially outward. Electric field is also in the same direction, that means theta will become 0. So cos 0 will become 1 over here, and due to symmetry of the surface, electric field will be same at each and every point. So electric field can be taken out of the integration. So it is E integral ds, that means E into 4 pi r square. Last step, fourth step, to compare equation 1 and equation 2. This was the fourth step. So we have E into 4 pi r square is equal to Q upon epsilon naught, which gives us that electric field is 1 upon 4 pi epsilon naught Q upon r square. That's it.